All right, welcome to class, everyone. We are going to continue from where we stopped the last time. Just like I've said earlier, we are going to have a complete video on longitude and latitude, and that's what we have started. And right now, we'll be introducing us to how to calculate radius of the Earth's surface and also the radius of parallel of latitude. All right, so let's get down to what we have. I want us to understand certain things about this calculation. First and foremost, I want us to know that the Earth is a sphere, of which this is very common. This is all what everybody should know, and that its radius has been calculated already, and it is approximately equal to 6,400 kilometers. Of course, in our questions, unless otherwise stated, this is going to be what we will always use to solve our problems. So the radius r, which is 6,400 kilometers, is the radius of the Earth taken from the center O of the sphere. We'll be looking at that sphere in a GV, but I want us to understand that we need to have this at the back of our mind, and that the radius is the largest radius on the Earth's surface. That is the radius of all great circles, in other words, the longitude and equators. So just like we said earlier, that all longitudes are great circles, and only the equator, among all other latitudes, is a great circle. All right. So similarly, other small circles on Earth's surface have their separate radii, which is designated by or denoted by a small letter r. Okay. So this is what we are talking about. We see the figure A and B. This actually shows us clearly what the circle is all about, the sphere, and you'll be able to see that we have our radius, which is capital R, just like in our elementary math. When you have a circle and the center of the circle is drawn, any line you draw from that center that touches the circumference, we say that that happens to be the radius. All right, so we can have several radii as far as the line is coming from the center of the circle. So the same way is what is applicable here. We have the center of the Earth, and any of the line you draw from the center that touches the circumference automatically produce a bigger r. So that's why we say that it is, of course, this is the equator that is shown here. The equator is a great circle, and all meridians are also great circles. So from the center, as far as the line is coming from the center of the Earth, this is the O that we are talking about in the previous statement. So we have it that from here to here, you are going to have your R. This is also R. Of course, from the center to S also is R. From center O to W is also R. From O to N is also R. So we have different, as far as the lines are, I mean, this thing is emanating from the center. So we say this is radius, this is the bigger R. Then on the other side, we have the small letter r. In this case, you see this is a small circle. Of course, all other latitudes are small circle because they are not coming from the center. They don't have their base on the center of the Earth. So of course, they have their own center, they have their own radius too. But in this case, we refer to them as a small r. So they are what we refer to as the radius of parallel of latitude. So we denote them by small letter r. Okay, I believe we understood that about this. So without wasting time, let's also look at some of these issues regarding the relationship between r and the capital R and the small letter r. So this diagram will show us clearly of what is expected of us, what we are to do. Now you see, of course, from our elementary math, we see that let's assume this is P. XP and OE are parallel to one another. They are parallel, okay? And of course, this angle will be equal to this angle because they are alternate angles. So we have that XPO will be equals to POE. Yeah, because they are alternate angles. So they are alternate angles. They are alternate angles, sorry. So they are alternate angles. So we are able to see that they are alternate angles. So why, if this is alpha, it's also going to be alpha. All right. So if I want to consider this right angle triangle that is here. We have this. This is X. Of course, this is P, and this is my alpha. Right. So this is my R. This is my small letter R. Okay. For my elementary maths, what we refer to as the SOHCAHTOA. The SOHCAHTOA. We call it SOHCAHTOA. Okay. We'll see that we have this is the hypotenuse side, and this is the adjacent side. So we have hypotenuse adjacent. So that's cos. Hypotenuse adjacent. That's cos. So if we say cos alpha is going to give us the hypotenuse, the adjacent over hypotenuse, rather adjacent over hypotenuse. So we have R over capital R. Okay, because that's what cos of the angle will give us the adjacent over the hypotenuse side. All right, so when we cross multiply now, we have that R is going to give us the bigger R multiplied by cos alpha. Okay, now this is a relationship that we are trying to establish. This is a relationship between R and our small letter r. So this is the radius of the great circle, and this is the radius of small circle. So this is the relationship. And don't forget, very important, that this alpha is actually latitude, is the latitude angle that we are having here. This very latitude is the one we are referring to. This alpha is a latitude angle. So in case you have a question, as we'll be looking at some questions, so this is a very good relationship that I want us to bear in mind. All right, so let's look at some questions very quickly. This very question asks us to calculate the radius of parallel of latitude, given that r is equals to 6400. All right, so very quickly, we know that r is equals to capital R cos alpha, and I told us that this alpha is our latitude angle. All right, so in this case, this is the latitude, because I told us from previous videos that we normally identify lines of latitude using by this north and the south direction. So we normally use this to identify them. All right, so now when you have this, so simply what we need to do is to just say r is equals to 6400 multiplied by cos 54, okay, degrees. So this is going to give us the answer. And if I pull up my my calculator, if I put up my calculator now for us to see, I want us to see this very clearly. So you are going to notice that if we do 54, we have 54. The cos of it is this. Then multiply by 6400. When you do this, we are going to have our answer to be 3761.82. 3761.82. So we have 3761.82 kilometer. That is going to be the answer for this. All right, very quickly for this one, we are going to have r cos alpha also, which is going to be 6400 multiplied by cos of what? The latitude. This 29 degrees. So when we do that again, we are going to have the calculator now is going to give us 6. The cos of 29. So we have cos. 29 cos of this. Okay, multiplied by 6400. Okay, that's 5597 point. Let's say 5597.56. Okay, so that's going to give us 5596 point is this 71 or so. So this is just what we need to do. In this case also, very quickly, you know that this is going to give us r. of course, it's going to give us r again. So this particular question is very easy, doesn't require much. Once you know the formula to apply, then it becomes easy thing. This one also is once you identify the latitude, then you know that this is 64 multiplied by cos 12 degrees. So when we do this, you see that you have different answers to the question. I believe we understand this. So basically, the relationship between r the radius of parallel of latitude and that of the radius of the earth is this. So once you remember this very expression, this formula, this is what you'll be using whenever you are asked to calculate the radius of the parallel of latitude. So this is what is this is also going to help us when we get to calculation on distances. I believe you enjoyed this video, and please try as much as you can to go through it. I know it's not something difficult. Just we need to just memorize this formula, and I will see you in the next video. We'll be looking at how to calculate distances on great circle and small circles respectively. Thank you very much for watching. Please like, share, and also make comments in the comment section, and the Lord bless you even as you do so. Thank you very much. See you in the next video.